Let's continue with our study of basic Linux commands. So we've covered some of the items that you're likely to encounter on any Linux system, and for that matter on any Unix system. TTY, who am I, which, echo, set, clear, history, pwd, various bash features, ls, which you'll use more than most commands. And we should continue. Let's label this command number 15. That's the cat command. Cat is short for catenation. It allows you to catenate files. It also allows you to enumerate the contents of a file, in particular a text file, to stand it out, and can be optionally used with redirection to catenate the contents of a file to a new file, using redirection, of course. So cat catenates files, but its normal behavior is to dump the standard out. So cat, for example, the name of a file, dumps the file to stand it out. Now we need a file to focus on, so let's lsltr. Let's look at the notes file, for example. We'll copy the name and simply cat Control-Shift-V to paste the name of the file. And there you see it dumps to the screen, including all the lines which contain blanks, the contents of the file. But you can use cat to combine multiple files. So for example, let's create, if we don't find one, multiple files. We'll use nano, and we'll create one file with 1, 2, 3 on 3 separate lines. And we'll save this as 123.txt. Then we'll nano 456.txt. Nano is a text editor which allows you to manipulate text files. 456. So using cat, we can cat 123.txt as well as 456.txt. However, if you want to cat both of them, 123.txt as well as 456.txt, both are dumped to the screen in a nice, neat order. So, cat 123.txt dumps the contents of 123.txt to stdout, or standard out, whereas cat 123.txt followed by 456.txt dumps both files to stdout, which means if we combine cat with output redirection, we can send the contents of one or more files to a new file. For example, cat 123 456.txt greater than symbol, which is the output redirection symbol, to a new file, which we'll call 123.456.txt, we'll create a new file. Creates new catenated file. And based on this simple example, you can see how powerful cat can be when manipulating textual data. So, let's clear screen, and we'll execute our command using Control-Shift-V, and we'll echo the exit status. It's always a good idea after you execute Linux commands in a bash shell to echo the exit status, which is stored in the question mark variable. $ references variables. Question mark happens to be a variable which stores the exit status of the most recently executed command. Whenever it returns 0, this tells you that the command executed successfully as far as it was concerned. So now let's cat the contents of 123.456.txt, which we'll use tab completion as we've just done. Simply type in the unique characters 1, 2, 3, 4, then tab it out. Now you see the file contains the entries from both 123.txt and 456.txt. So use cat to catenate text files. It doesn't limit you to 2 text files. You can catenate as many text files as the program will support, sending the output to a file that can be used. And you can use cat in conjunction with other programs such as sort to sort the data before re-representing the data in a new text file. But there are other commands, so we're not going to spend too much time working with cat. Let's move on. Supposing you want to make a new directory. Very simple command. make dir. This creates a new directory. Instead of md, which you may be accustomed to from Windows, make dir, and we'll give it a new name such as test rh5, for example, creates a test rh5 directory in the directory that you're currently in. If you need to make a directory elsewhere, then indicate the full path, the absolute or relative path. So make directory test rh5, and now in lsld, test rh5 reveals that the directory has been created. However, it doesn't contain any files, but it has been created nonetheless. So make directory does exactly what its name implies, and that is to create directories for your usage. Directories are files that are containers for other files. So within test rh5 we can create files. Now what if we wanted to copy items into test rh5? 17 cp, instead of copy, as you may be accustomed to from Windows, cp is the equivalent. cp copies files. So, for example, cp 123 star or 123.txt to test rh5 will copy the item into rh5. Let's give this a try. It's a very simple command again, but you need to know it. So in this directory we've got 123.txt. Let's copy it. And an echo of the exit status returns successful. So now an lsltr of test rh5 reveals that there is the file 123.txt. However, 123.txt also exists in our current directory, which means we're doubling up data. That means we have two copies of the data. Also notice when you copy a file, it doesn't preserve the modification time. It creates a new modification time because a copy creates a new file. Whereas had we moved the file, the original modification time would have been preserved. So we should just note that. By default, cp does not preserve the original modification time because it creates a new file, which means it has new attributes. So that's copy. Very simple, and there are options such as verbose if you want to see what's happening. So cp-v, let's go with 456.txt to test rh5. This will turn on the verbose option. So cpv 456.txt into test rh5. It tells you what it is copied. And you can follow that up with an echo of the exit status to be sure that the file was successfully copied, which now means an LSL of test rh5 reveals both files. But again, both files also exist in our current directory, home Linux CBT, as well as home Linux CBT test rh5. So we've doubled up the data, which gives us opportunities to use two other commands. Let's move on. The 18th command is mv. This moves files. So for example, mv 123.456.txt to test rh5 moves the file, preserving timestamp, and that's the modification timestamp. So let's try to move, and by the way, move supports the V option for verbose. In fact, most Linux commands support the lowercase v option to indicate that a level of verbosity should be employed, which usually means that the program will return to standard out useful information for you, the administrator. So let's move -v 123.456.txt into test rh5. And just like the copy program, it returns what it has done, and just like we did before, an echo of the exit status will return whether or not move performed accordingly, and it has. So the true test is to test whether or not, or to check using the ls command, whether or not 123.456.txt exists in our current directory. ls tells us no such file or directory. and echo of the exit status returns a non-zero value indicating that ls did not perform successfully. So that now means in test RH5 there should be 3 files, 1, 2, 3, 4, 5, 6, as well as the other 2 files. And also notice, since we're ahead of 1234, that the original timestamp on 1, 2, 3, 4, 5, 6 has been preserved. So move preserves the file stamp by default. Doesn't mean copy can't do it, just means the nature of move and copy are different. When you move, you don't create a new file. You basically cut and paste. When you copy, you create a version of the file that's identical to the original file, but indeed the new file is a new file, or the destination file is a new file. Now there's still other commands. Now we need to do some cleanup. It's always good to be organized. So since we've got all 3 files that we've created thus far in test RH5, let's remove the traces that are in this directory. And LSLTR will help us to sort towards the bottom what we have recently created, and then we'll remove these items. RM followed by a list of files such as 123.txt, 456.txt will remove the files. Echo of the exit status returns successful. RMRF will ensure that if it's a directory, the items will be removed recursively, and it will force a removal of the file or files or directories and files and or files. So that's RMRF 456.txt, and the exit status is clean. So that leads us to the 19th command, and there are literally hundreds if not thousands of Linux commands. So get used to having to memorize them, but the more you use the system, the easier it will be to remember them. So RM removes files or directories. RM 123.txt or RMRF 123. In our case, we did 456.txt. This removes recursively and forces the removal, forcing the removal. So RM is another command you need to know about. Again, when you're removing directory structures, you can't remove them by default if they contain files and or directories without the assistance of the recursive option. The remove command will complain that there are entries in the directory you're attempting to remove, which is why you need to indicate RF. However, no need to memorize all the options, just RM-help, and you'll see that F forces and R performs recursively. V verbose, just like with copy and move. So we've covered quite a few commands thus far, but they're self-explanatory, straightforward, and they're very helpful, especially if you're new to Linux or relatively new to Linux and want to have a sense for the commands that you are accustomed to from a Windows environment. And even if you're coming in from Windows, it doesn't necessarily mean you're terribly familiar with DOS commands, since Windows obfuscates most of the shell-based commands by imposing the GUI on you. So if you're new to Linux, get used to having to know or remember tens if not hundreds of useful commands, and they're very easy because they're named sensibly based on their purpose. So we've looked at cat, make directory, remove. There's also remove directory. We've talked about set, history. There's also the touch command. Touch creates blank files or updates timestamp. For example, touch in our test.rh5 directory, test.txt, will create a 0-byte file if it doesn't exist. Let's give it a try. We'll use our cd command to change into test RH5, clear screen, reset the buffer, and then execute touch test.txt. We'll echo the exit status to ensure that all went well. And now when we lsltr, you see that the most recently created entry, test.txt, is a 0-byte file. However, let's say we want to update the timestamp of any of these other files. Use touch followed by the name of the file, and the timestamp will be updated. So let's update the oldest file, the file created at 1234. And that's the 123456.txt file. So touch 123456.txt will update the timestamp. Let's give this a try. And then we'll lsltr, and it'll now be at the bottom of the list with a timestamp of 1247. So touch updates it, it doesn't change it. It was 12 bytes and still is 12 bytes. However, touch is even more flexible. Supposing you wanted to apply a specific timestamp to a file. Execute touch --help and you'll see the syntax. Touch followed by T for the timestamp, followed by the format that you see here, which includes the century, the year, the month, the date, so on and so forth, will allow you to apply the timestamp of your choosing. So for example, 123456 has today's timestamp. What if we wanted to set it to, let's say, yesterday's timestamp? So we'll go ahead and touch T, 2008, 01, 09, with a time of, let's say, 1530 hours. So setting it to 1530, 123456.txt. We'll echo the exit status, and now when we execute lsltr, 123456 will revert to the top of the list because it now has a timestamp of yesterday. So let's just document this. Touch also allows us to change the timestamp, but that's what we meant when we indicated that it updates the timestamp. Not only does it update it to the default, by default, it will allow you to update it to whatever you want to update it to. So this changes timestamp entirely. Now you may be wondering, isn't this a security flaw or grounds for a breach? Well, there's yet another command that can help you to determine the attributes, especially time-related attributes, since that's the context that we're currently in within Linux, and it's called stat. Stat reveals statistics of files. Let's give it a try. Stat 123456.txt reveals full attributes of the file. This is a very useful command. So if you casually search a directory tree using ls and see timestamps that seem to be off, penetrate or perform a deeper investigation using stat. So stat 123456.txt, for example, reveals some interesting information. It tells us here that the file was last accessed at this particular timestamp, so it has yesterday's 1530 timestamp. It also believes it was modified yesterday at 1530, but it also includes a telling piece of information, and that is that the file's attributes were changed on the 10th, or today at 12:48, and relative to the current time, that's about 2 minutes ago. So although we've changed the timestamp to make it appear as if the file had been created and modified yesterday, stat tells us the truth if we look at the change field, and that is that the attributes were modified today, literally 2 minutes ago. Stat also returns other information: the name, its size, the number of on-disk blocks, I/O block size, the fact that it's a file versus a directory, permissions associated with it, its inode, its device where it can be found, its inode, the number of links. Files without additional links usually have 1 to indicate that the name is linked to the inode, and if you link to the file after that lone link, then it will be 2, and so on. And as mentioned, the permissions associated, but we'll look at permissions later on. the UID of the owner, the user ID, so it's owned by the user Linux CBT who has an ID of 500. The GID, and in a Red Hat environment, UIDs and GIDs tend to be the same. So if you're logged in as root, your UID will be 0, your GID will be 0. You're logged in as, let's say, the first created user, you'll begin, or that user will be assigned UID 500 and GID 500. And again, as mentioned, access, modify, and change information is returned by stat. Many scripting languages such as Perl, Python, PHP, Ruby, so on and so forth have hooks into the stat functionality in Linux as well as other operating systems, and can easily access these bits of information such as when the file was changed versus modified versus access, in addition to the permissions, size, blocks, so on and so forth. So stat's a very useful command in that regard. It tells you the truth of your files. The attributes, the full attributes. Stat 456, let's stat test.txt, although it's an empty file, tells you exactly when the file is created. Now if you touch or create an empty file, the attributes for all of the time-related fields for access, modify, and change, or 3 time-related fields, will be identical. Ditto for other files that were created on the fly using a process versus user interaction via a utility such as Nano, for example. So stat is yet another useful command in addition to touch, remove, move, copy, so on and so forth. Another useful command is find. With thousands of files on your Linux system, you need to know how to find files on the system using search patterns. So finds files using search patterns, in particular wildcards, but it can be programmed to use regular expressions. So for example, let's say we're looking for etc fstab or the file fstab anywhere on the file system. So a find followed by where to search, or from the top of the tree, followed by the keyword name, and in between single quotes, fstab. Now if you're not sure if the file is exclusively named fstab, then wrap it with wildcards, for example. This will help you to find variations of fstab, but if you are sure that this is the name of the file, then you can execute find in this way. So find followed by the path to search, such as /, but you can indicate a specific tree such as etc or any directory level, followed by the keyword name, followed by the pattern to search for will search for the file for you. Find supports many other options, including regex support. Let's go ahead and reset this buffer. And then we'll Control-Shift-V, and this will search from the top level of the directory tree. Permission denied will be returned quite often because non-privileged users are not allowed to search certain directory trees. However, eventually, our system will find the fstab file. And even when it's found one instance of fstab, it will continue to search for other instances throughout the directory tree. Now, just a quick warning. A find search from the top level of your directory, which is the root directory, can take a while, especially for systems that contain thousands of files and hundreds of programs. So just bear in mind that it can take a while, and it will use or tax your system to find it, which is why there's an alternative, the locate program, which maintains a list of files on your system, files and directories on your system in a database which is searchable much more quickly, but it requires updating, whereas find searches on the fly. Here's etc fstab. It's found one instance, and guess what? It's over. The find is over. It returned a 1 because the last search, or the last tree that was searched, failed, but it did find etc fstab. If a search using find exceeds your buffer, you can always dump this information to a file and then parse it after. You can also narrow your search. Let's say we know that fstab should be beneath, or the important fstab file should be beneath the etc tree. Then indicate etc. This will quickly find the file. And it will also continue to search other subdirectories of etc. You can also instruct the find command to limit its search to one directory, but then that defeats the purpose of using find. Find works recursively by default, whereas we could have used ls with a simple etcfs tab to see whether or not it exists, and indeed it does. So find is a useful command. Again, just like with the other commands, find -- help will return the different ways you may search. You can search for files based on attributes, based on the size of the file. For example, if you want to search for files that are greater than 500 megabytes, you can use the size option, or smaller than 4 gigabytes, or with certain inode numbers, or with certain modification time information. Pretty much all of the properties that we've seen, let's stat etcfs tab, that we've seen with the stat command can be searched using find. All of these different fields. So let's note that find can search for fields returned by the stat command. So pretty much all the information you see returned by stat you can pass into find using some syntax, and it will find it for you, or not find it for you, and return an error regarding the inability to find the file. Now there are just tons and tons of other commands left for us to explore. Another command is a bash built-in command. It's called alias. Alias returns and optionally sets aliases for commands. For example, let's just execute alias. Alias dumps current aliases. An alias is great when you want to run commands in a certain way that the system considers non-standard. For example, to customize or further customize your environment, you may want every time you execute ls that it turns on the colorization option. That's a -- color equals TTY. That way, when you list directories, you see those directories, for example, like the test RH5 directory, which we're currently in, so let's LSLD. You'll see the test RH5 directory in the color blue. You'll see standard text files in black. You'll see tar compressed images in red, images in this fuchsia purple color, executable files in green. Alias dumps the aliases for different commands. For example, if you were to type L at the command line, it really executes ls with the D option. If you were to type LL, for example, it runs. Let's dump that alias again. It runs, and in this case the alias is set for L dot, so we missed the dot. So if you type L dot, it dumps the directories that are available, as well as any hidden files. So directories and hidden files. Here we see hidden files and directories. If you type LL, it dumps the directory in long format with colorization turned on. Basic LS dumps information in short format with colorization turned on. If you execute the popular VI editor, it really calls VIM. If you execute which, it too is also an alias. And you can add aliases to the list to further customize your environment. Depending on how you like to run your commands, you can set up aliases. Aliases can be defined on the fly. For example, let's set an alias for copy, the DOS version of copy, meaning to be able to call it the way we would from DOS. If you look at the syntax, it's simply alias followed by the way you'd like to call it, equal, and in between single quotes the way it should be run. So alias copy, and copy is going to be equal to whatever we indicate here. CP, perhaps with the V option turned on, so that when we copy or when we execute copy using COPY, it does so with the verbose option. Let's go ahead and set it. Now this applies to our session on this pseudo terminal, which is pseudo terminal number 2. Doesn't impact pseudo terminal number 1 or 3. Now let's go ahead and rerun alias, and you'll see that there is now an alias for copy. So this means whenever you execute copy, it will execute -v, but you have to have something to copy. So for example, we'll copy ks.cfg to test RH5, and we'll ultimately remove it. And there you see the verbose option was enabled because we see the results of the copy process. Now when we navigate to test RH5, you'll see the ks.cfg file, which we'll remove. So let's remove ks.cfg. So we've created one alias, and we also mentioned that if you were to open another shell, you would not see copy as an alias. And there you see, there's the full list. So you may be wondering, how do you impact the alias update across the board? Well, that has to do with the default file read by the bash shell. The bash shell reads a series of files. If you ls.bash and just tab it out, there are multiple files, including what happens when you log out of a bash session, where to keep the history, and the important profile files, profile and bash rc. Either of these files can be updated to store alias information, either bash profile or bash rc. Either one. Bash profile tends to export variables, such as what we see here, path, home, bin, and it's subsequently exported. Bash rc tends to source functions, but either file, both files are read whenever a bash session is launched, so you can place your aliases in the bash file. And there's also a global bash file from where these aliases are defined. So when you define an alias, and for that matter many variables in one shell, it has no impact on the other shell. In order for your settings to persist, you have to update the global or user-based configuration file. Otherwise, the settings won't persist. Now again, there's still more commands for us to look at. We'll look at them next, and then we'll also look at compression using bzip, gzip, as well as zip and rolling files with tar, all as a part of our basic exploration of Linux commands.